Minerals by Kate O'Donnell. Minerals are naturally occurring inorganic solids with definite chemical compositions and ordered internal structures. Naturally occurring means that minerals form in nature. People do not create minerals. For example, steel is not a mineral because people make it. Gold is a mineral because it is found in nature. Inorganic means minerals are not made by an organism. For example, pearls are not minerals because oysters make them. Solid means that minerals are not liquids or gases at standard temperature and pressure. A definite chemical composition means that the same number of atoms always combine to form specific minerals. For example, a molecule of quartz is always made up of one silicon atom and two oxygen atoms. Finally, an ordered internal structure means that the atoms or molecules of minerals form regular and repeating patterns. For example, halite has a cubic crystal structure, and quartz has a hexagonal structure. Minerals can either be made up of one type of element or multiple elements and molecules. Minerals made up of one element are called native elements. Gold, silver, and carbon are all native elements. Multiple minerals can come from the same native elements. For example, diamond and graphite are both made up of pure carbon. Calcite, made up of calcium, carbon, and oxygen, is an example of a compound mineral. There are over 4,000 different minerals on Earth, and most of them are compound minerals. Minerals form in two ways. First, they can form when magma or lava cools. The chemical composition of the magma or lava determines the type of mineral that develops. The slower the liquid rock cools, the larger the mineral crystals grow. When lava cools quickly, only minuscule crystals appear. Sometimes the lava cools so fast that no crystals have time to form. For example, obsidian has no crystals. Crystals also form when cations and anions dissolved in water fall out of solution when the water evaporates. Most minerals are compounds made up of positively charged ion called a cation and a negatively charged ion called an anion. Cations and anions separate when they are dissolved in water and join together through ionic bonds when the water evaporates. Minerals can form from solutions anywhere water is found. For example, massive halite deposits formed in the Midwest and Southwest as ancient oceans evaporated. Today we classify minerals based on their chemical composition, but for hundreds of years mineralogists grouped them by their physical characteristics. Some physical characteristics include color, crystal form, hardness, luster, density, magnetism, and cleavage and fracture. While easy to determine, color is unhelpful for classifying minerals because many minerals are the same color, and one mineral can appear as several different colors. For example, quartz can be clear, smoky, pink, purple, or yellow. A mineral's color is determined by the atoms within. Ruby and sapphire are varieties of the corundum mineral, but ruby has traces of chromium within it, and sapphire has traces of either iron or titanium. A streak test gives the color of a mineral in powder form. To perform a streak test, scrape a mineral over a piece of unglazed porcelain. For example, gold and pyrite look the same, but gold has a yellow streak and pyrite has a black streak. The crystal form is the shape of a mineral's crystals, and it is determined by the structure of the atomic bonds that make up the mineral. Unfortunately, we only see crystals when they have space and time to grow. For example, quartz within a geode will form large hexagonal crystals, but will only form small amorphous crystals within granite. The most common way to test the hardness of a mineral is a scratch test. Scratching a mineral with a nail will determine if the mineral is harder or softer than the nail. In the 1800s, Friedrich Mohs, an Austrian mineralogist, created the Mohs scale to rank minerals based on their hardness between 1 and 10. Today we have more accurate methods for determining a mineral's hardness, but many mineralogists continue to use Mohs scale because it is easy to remember and use in the field with few tools. Luster describes how a mineral reflects light. The two main types of luster are metallic and non-metallic. There are even more specific groups, including vitreous, pearly, waxy, resinous, adamantine, greasy, silky, and dull. Density describes how tightly packed the atoms or molecules of a mineral are. Gold has a density of 17.65 grams per centimeters cubed, and iron has a density of 7.6 grams per centimeters cubed, so gold is denser than iron. In the field, experienced mineralogists can estimate the density of a mineral by holding it. Magnetism describes how minerals respond to magnets. Iron and magnetite are examples of minerals that will stick to magnets. Cleavage and fracture describe how minerals break. Some minerals have weaknesses within their atomic structures. These are places where the bonds between atoms or molecules are not as strong as the bonds around them. For example, mica has layers held together by weak hydrogen bonds, so the layers break off in flat planes. When the layers of a mineral face break away, a new face is left in its place. While only some minerals have cleavage, all minerals fracture. A fracture is any break in a mineral that doesn't remove a complete layer. Mineralogists classify fractures based on how the edges of the minerals look after they break. A conchoidal fracture creates concentric ripples similar to those seen in a mussel shell. Minerals with conchoidal fractures usually cooled quickly and are made up of tiny crystals. Earthy fractures look like freshly broken soil. They happen in soft minerals such as limonite and kaolinite. Hackley fractures are jagged and sharp. They happen when metals like copper and silver tear. From the Middle Ages until the 1800s, mineralogists carefully studied the physical properties to organize minerals into groups with similar characteristics. Then, in the late 1800s, Yale mineralogist James Dwight Dana developed a classification system based on the chemical composition of the anions of the minerals. He named 7 major mineral groups based on their anions, including silicates, carbonates, halides, oxides, phosphates, sulfates, and sulfides. Native elements are the 8th major mineral group. There are also minor mineral groups that are uncommon on Earth. Around 90% of the minerals in Earth's crust are silicates. Silicates are also abundant in the mantle. Rocks are made up of one or more minerals. For example, granite, a common igneous rock, is made up of the minerals quartz and feldspar. Rocks are also different from minerals because they can contain organic material. For example, coal mainly comes from the remains of plants, so it is a rock, not a mineral. The end.